So we are going to talk about best practices for running databases on Kubernetes. So first I should ask you, how many of you guys thinks running database on Kubernetes is a good idea? Anyone? No one. Okay, well that's is a tough crowd, and that makes it interesting. So let's talk about it, and let's hope we can convince you. Well, then the next slide is kind of a moot point. I was going to ask you which database you run on Kubernetes, but probably none of them, right? Or anyone run database on Kubernetes, even though you all think that is an absolutely horrible and terrible idea? Anyone? CrossDB. Okay, yeah, makes sense. Well, look, I think the running databases on Kubernetes is doable those days, and I will try to convince you about that. And I think this is in particular good because if we are looking at the modern public cloud, we kind of find ourselves a little bit in a bait and switch situation, right? From one standpoint, we would see them used to advertise in the clouds as something akin to electricity, but then, especially when it comes to the database standpoint, there is a lot of focus on saying, hey, no, use our proprietary solution. You know, Amazon Aurora, DynamoDB, Google Spanner, you name it. Right, which is in the end creates a vendor lock-in and gets you in a very expensive place. So you are, of course, right in certain things about running database on Kubernetes. Kubernetes is very well known being created for stateless applications. And databases are quite opposite of stateless, right? That is where the state is. Though you can see there have been a lot of work put into running stateful application on Kubernetes. There is actually this kind of like a sub-community in the Kubernetes or cloud native space called Data on Kubernetes. Anybody heard about it? DOK? Well, you can, check it out, right? And they have a track in many of the KubeCon conferences, and there is a lot of best practices out there on data-intensive applications on Kubernetes, much more than I would be able to do. Now, one thing I did, I grabbed some of their stats, right, from one of the recent online presentations they have from the survey they did. And what they see, unlike you guys, there is a fair amount of respondents believe what the Kubernetes is ready at this point for stateful workloads, and actually a fair amount of people, 70%, is even running some stateful workloads on Kubernetes those days. Now, if that is not enough as a proof point, I think what is very interesting is what you will find a lot of newer database as a service solutions, right, are actually using Kubernetes underneath, right? And for me, because we don't constantly have, oh my gosh, all data lost for all the customers, right? Well, we can see what that is a possibility to do with reasonable availability, efficiency, and so on and so forth. Right? So that is doable, and actually there are probably millions of database instances out there running on Kubernetes those days. Well, anyway, I made my pitch, and now let's talk a little bit of the best practices specifically if you dare to take that leap of faith one day and run a few databases on the Kubernetes. The first one, which I would recommend, is to use operators. Are you guys familiar with the concept of Kubernetes operators? Yeah, so if you think about deploying database Kubernetes, actually there's many ways, right? You can just, grab and deploy a Docker container, right? Or there's a few other things. But really doing that may work for simple development environment, but the thing of a database being stateless, it spends a lot of time in day two, right? It needs to be maintained, kind of constantly updated while it is in production, right? We cannot just, remove our database and redeploy it in initial state of an empty database when we don't like it, right? Database cannot be immutable. Database tends to be needed to be, upgraded. You have to do all that kind of fancy thing in terms of backups, maybe scaling the cluster size, and so on and so forth, typically while being up. And that is what Kubernetes operators provide versus, more simple deployment strategies don't. Second one is, of course, you have to set up high availability from the ground up. Now, if you look at our non-Kubernetes world, especially bare metal, you often would have like some highly reliable server which has like an uptime of 5 years. It never went down, never crashed, right? Humming along, right? And that means in many cases you can say, well, I don't actually need like a real high availability. I'm taking the backups, and you know what? If it crashes, I restore from backup, that is not a big deal. That is probably not a good idea in Kubernetes, right? In Kubernetes, you really want to avoid relying on availability of a single instance, right? And that especially makes a lot of sense if rule number 3, you want to make sure you set up a proper storage, right? In certain cases, having their persistent volumes, right, which are backed by external storage, right, or makes sense. In other cases, when you have especially replication database engine levels, your local disk, fast NVMe or something like that may make a lot of sense. But you have to invest in configuring that, not just saying, hey, I deploy the container, right, and it will use that kind of ephemeral storage which will disappear when the pod is destroyed. Now, you also likely want to keep your data per pod relatively small, right? If you're saying about, well, I have this, single 50 terabyte database which is not sharded, well, maybe having that on Kubernetes is not a very good thing. Now, if you're looking at the more, either databases like you mentioned, CockroachDB or some other databases which are shard the data already, right, and use kind of a smaller pods, or use some sort of like a sharding solution, wherever it's kind of a manual solution, or technologies like VTS, for example, for MySQL, they all tend to keep the data per pod smaller, right, so it's easier and faster to deal with. You also want to make sure you use appropriate node size. I've seen a lot of Kubernetes systems designed for small applications say, well, we deploy relatively small VMs, and in that case, there may not be very good setup for deploying larger databases, because you know what, if you are looking to move a database which was run on, let's say, 128 core machine with half a terabyte of memory, right, or wherever, well, probably you want the same kind of physical node backing up your Kubernetes as well. In many cases, actually, when we see databases deployed on Kubernetes, right, they will be sole tenant on the given physical node, right? So you kind of get the similar performance to your bare metal deployments, and don't have to deal with things you don't need to deal with, like noisy neighbors and so on and so forth. Now, what you also probably want to do, especially for databases in a production, is configure resource and request limits, right? Because if you don't, then your database performance may be not uniform. And that is often we don't like with databases, right? You want database performance in production to be predictable. If there's not enough resources, you want to find it out, right? And not kind of hope, oh, it works well now, and then because of somebody else grabbed, all the CPU load, database cannot serve in normal traffic, right? Again, in development, you probably don't need that, but in production, you want to set that. Next one, you want to make sure you use proper anti-affinity. Again, if databases, the availability is the top concern. So for example, you don't want to have a highly available cluster, then all the nodes of that cluster end up provisioned on a single node. Bad idea, right? Or maybe you don't even want them to be in a single rack, right? Maybe you want them to be in the different availability zone, right? And you can configure that if anti-affinity rules to be deployed according to the high availability you want to get. Next, Kubernetes is not magic. You still want to make sure you tune your database, right? And we have seen that people just using default configuration, which may not be a good idea, right? And neglecting things like indexes. At Percona, actually, we have a pretty good tool for that. It's an open source tool called Percona Monitoring Management, which can help you to optimize settings as well as to understand what queries are causing the most load in your environment as well as tune them. Next, you want to understand how to scale. You want to understand how to scale the databases. There are some databases which can be scaled out, right? There are some others, like if you think about MySQL or Postgres uncharted, well, you actually have to pretty much scale up, right, in this case. Again, in a Kubernetes concept, and you often just say, well, we can deploy increased number of instances. That's not always work the same way with databases. We also typically want to control eviction priority, right, because database is something which is rather expensive to deal with, right? If you kill the database node, it's often may need to do a crash recovery. Even if it doesn't have to do that, often it has to warm up, read the data, bring it kind of in memory before it starts to perform at the optimal stage. So unless you actually have to mess with your database, kill it and move it to another node, you don't do it. You don't want to expose your database outside of Kubernetes unless you have to. So many security issues comes from the exposed database in the internet. You also want to enable encryption, and that comes both with data at rest and data at transit. The important thing here is in a modern state of technology, CPUs and such, it doesn't cause significant overhead. Right, you can encrypt traffic and especially encrypt data at rest and relatively cheaply. Another way, security related, is you want to make sure you use Kubernetes secrets for configuring the access of applications to your database. Well, kind of obvious. Backups. Well. So many people we constantly see relying on your high availability solution and, instead of backups, and obviously these are not the same. No cluster will save you from somebody dropping the table in production instead of a test, right? So you want to make sure there are backups out there. You also may want to check the new generation of databases. There is a lot of work done having a database which actually designed specifically for cloud-native Kubernetes environment, right? There are some of them which are open source, right? And I think that is going to be more of them in the future. CPUs. That is also something very interesting, right? If those are available, look around what's accessible. We see right now a lot of providers provide ARM-based CPUs, which often tends to be less expensive, right, and more performant for certain workloads. So check it out. Now, when we also see different groups using different Kubernetes deployment modes, right? Some people deploy Kubernetes on their own, which has a benefit, right, of complete control. Others use their managed Kubernetes services by the cloud providers. Both have benefits and drawbacks. And the last one I mentioned is their look at resource utilization, right? I mean, if you have more nodes when you actually need to run that workloads, right, well, can be wasteful. And in Kubernetes, because of dynamic ephemeral structure, it's kind of much more, kind of maybe more invisible compared to your kind of very fixed bare metal infrastructure. Now, a few things beyond the best practices I wanted to touch on. One is I mentioned it's a good idea to use the operators. And there is now a whole bunch of them out there on the market, right? We at Percona also have our operators, right, which are some of the more mature in this market. They existed, for a number of years right now, deployed for in many large institutions. We have one for MySQL, PostgreSQL, and MongoDB. Next, I wanted also to talk a little bit beyond the Kubernetes operators. Now, when you come to a conference like this, here typically everybody understands the Kubernetes, loves Kubernetes, and so on and so forth, but not everybody is like that. We also have a number of people come and say, well, you know what? We just want something like an Amazon RDS. We understand your GitOps, but what you want is actually ClickOps, right? You want to be able to deploy the database in kind of couple of clicks, and all this kind of YAML and stuff in Kubernetes is kind of complicated, right? Well, and that is something what we've been working at Percona to fix. So we have their solution, which is called Percona Everest. And again, that is an open source project which provides you with kind of a graphical user interface similar to what you will see with RDS and other cloud services, right, allowing you to provide get a database cluster with backups and everything. So that is one project you may check out if you are looking to see what else beyond the operators. And the next thing I wanted to touch on is this tool. I've been, one of the projects I've been involved recently, it's called Karoot, and that's also open source project which gives you a lot of observability. It's not specifically designed only for database. It's actually like a full application observability for Kubernetes. But what it does very well for databases, right? Because we typically deploy a database cluster which have many components which kind of talk to each other, like there's likely to be, I don't know, so maybe if you deploy the Postgres, there's going to be, Patroni, and there's going to be some PG bouncer, and there's going to be all this kind of thing, how it plays out. Karoot allows you to see how those components to talk to each other, what exists, if there's any communication issues, latency, and so on and so forth, right? As well as getting like some other pretty cool features, like you can identify anomalies, you can identify risks. One also very cool feature it has is allows you to understand the costs, right, including node costs, traffic costs, which I think is a pretty pretty cool, and you can do that, get that all without any integrations required, right? It's kind of uses eBPF, so it can do a lot of things automatically for you. Okay, well, then thank you. Appreciate you coming to my session and spending your afternoon with me.